Alright, well, in this video I'm going to be working Algebra 2 Quiz 6.3, which is analyzing graphs of polynomial functions, so like determining whether a function is increasing, decreasing, where it's got a maximum, minimum, stuff like that. Okay, so we've got a third degree polynomial shown, and they're asking for what values is the thing increasing. We can do that. We know that increasing is where, as we move left to right, the graph goes up. So it's going to be right here, between x equals -3 and x equals -2. So I might say -3 to -2 like that, or I could say -3 to -2 like this. It doesn't matter how you're going to write your answer. We're good with either, right? And then I might ask, is the leading coefficient of f positive or negative? And give a reason for the answer. Okay, well, I can tell it's a third degree polynomial, first of all, because it told me it was a third degree polynomial. I can also see it's got two turning around spots, two extrema, so I know that that's evidence of it being a third degree polynomial, although not incontrovertible. Like, there are some polynomial graphs that have two turnaround spots and could be a fifth degree polynomial, but maybe talk about that a different day. We don't even need to worry about that to determine if the leading coefficient is positive or negative, because we can determine that from the end behavior. Right? Okay, we're seeing that as x goes to negative infinity, y is going to positive infinity, and as x goes to positive infinity, y is going to negative infinity, and so that means I've got a negative leading coefficient. Okay, and then the reason would be, I suppose, the degree of the polynomial is odd, and that also as x approaches positive infinity, y approaches negative infinity. Oh, let's see. My writing's not showing up. Alright, there we go. Okay, so let's move on. Now we're going to be shown the graph of what looks to be a fourth degree polynomial, and I think it's a fourth degree polynomial because I'm seeing three turning around spots, three extrema. I know it's going to be an even degree polynomial because, on both sides, both of the arms are going up. Okay, so I know there's probably a fourth degree polynomial with a positive leading coefficient. I know for sure it's an even degree polynomial. Okay, so where does G have a relative minimum? Okay, right here and right there, places where the graph goes from decreasing to increasing. So I would say, well, that would be at x equals 1 and x equals 5. And what's the minimum possible degree of G? I'm going to say that the minimum possible degree is 4 because there are three extrema. Right now we're going to see the graph of a polynomial h of x, and okay, again, maximum and minimum. All right, well, we can probably do that. Let's say, all right, maximum right here at x equals 5. There's going to be a minimum right down here at x equals 4. And, oh, okay, that's all they asked. Okay, great, we can do that. So, now we're going to be given some polynomials algebraically and asked similar questions about it. So does the graph of y equals 3x squared times x minus 1 have a relative maximum or a relative minimum at x equals 0? Show the analysis that leads to your conclusion. Well, the analysis that leads to our conclusion is going to be sketching a graph. So we can do that. I'm going to go over here and we're going to say, all right, this is a third degree polynomial. Because I see x squared, that's 2 degrees, and then x plus 1, that's another degree, so it's a total of 3 degrees. It's going to have a positive leading coefficient. At least I'm not seeing any negatives multiplied in there. But I can see that the leading coefficient is going to be 3, because it's going to be 3x to the third plus 3x squared. Okay, so degree 3 with a positive leading coefficient means I've got, in behavior, kind of like y equals x cubed. That wasn't very good. I feel like I can draw better than that. That'll have to do. Okay, and then my zeros are going to be at x equals 0, which will be a double root. double root because of that x squared. And then x equals -1 would cause x plus 1 to equal 0, but that's just going to be a single root. Okay, so I've got -1 here and 0 there. Okay, the end behavior, I'm going to get rid of that arrow. The end behavior is showing me that this graph needs to come from below. Okay, x equals -1 is a single root, so it's going to pass through here confidently. But x equals 0 is a double root, so I'm going to see a bounce, and that's going to be the graph. Okay? So when it asks if it has a relative maximum or relative minimum at x equals 0, I'm going to go and I'm going to look right at x equals 0, and I'm going to say, oh, hey, that's a relative minimum. In the next one, they're going to ask us if the graph of this, what looks to be going to be a fourth degree polynomial, is increasing or decreasing at x equals 0. Okay, so we're going to do the same thing. We're going to produce a sketch of the graph, and then we're going to look right there at x equals 0 and see what we can find. Right, so this is going to be a fourth degree, because x, that's 1 degree, x plus 1 squared is 2 degrees, so I'm sitting at a total of 3 degrees, and then x minus 3 is going to be my fourth degree. All right, so I've got a degree 4 polynomial. The leading coefficient is going to be 1 if I was to square x plus 1 and distribute in x and multiply that by x minus 3. So I'm going to say that's an even degree polynomial with a positive leading coefficient. Looks kind of like the graph of x squared, at least on the outsides. And then I'm going to list out my zeros. I have x equals 0, which is going to be a single root. X equals -1 is going to be a double root. And x equals 3 would cause x minus 3 to equal 0, and that's going to be a single root. So, -1, 0, and 3. And so I'm going to respect the end behavior. It's going to come from above. X equals -1 is a double root, so I'm going to see a bounce here. And then the other ones are single roots, so I'm just passing through those x-intercepts confidently. And then if they ask, oh, hey, are you increasing or decreasing at x equals 0? I'm looking right there, and I'm seeing as I move left to right, the graph is going down. So I'm going to say that this function is decreasing at x equals 0. All right, now let's work form B. So here's the graph of a third degree polynomial. Where is the function increasing? Okay, so increasing is going to be where as we move left to right on the graph is going up. Okay, so that would be right there. So it's just going to be 4 to 5. And, if you wanted to write this in interval notation, you could definitely do that, but I'm just going to leave this in inequality. And then as the leading coefficient of f positive or negative, give a reason. I'm going to say, all right, the leading coefficient is going to have to be negative because this is a third degree polynomial. They told us it was a third degree polynomial. And I'm seeing this end behavior that I'm kind of coloring in red. Okay, so it's got to be negative. My reason would be f is third degree. And as x approaches infinity, y, or f of x, is approaching negative infinity. Now we've got function g of x and asking where it has a relative minimum. Okay, so we can find those. It's going to be right here and right there. So it's going to be x equals -1 and x equals 5. Minimum is a place where the function goes from decreasing to increasing. And that's what's happening right there. Okay, what's the minimum possible degree of g? Okay, and just like on the other form, I'm going to say this is at least degree 4 because there are 3 local extrema. picture of a graph and we're just asked about where the maxima and minima. Okay, that's a minimum right here because the graph is going from decreasing to increasing. So we're going to say a minimum at x equals -3. And then we're going to have a maximum over here where the graph goes from increasing to decreasing. So that's going to be a maximum at x equals -2. And then these last two are where we're going to be given an algebraic polynomial and we're asked the same questions. We're just going to produce our own graph. So I've got here a third degree polynomial with a positive leading coefficient. Specifically, the leading coefficient is going to be 3. And then I'm going to, what I'm going to do here, I'm going to list out my zeros. X equals 0 is a double root. X equals +1 would make that thing equal to 0, so that's going to be a root. And that's just going to be a single root. Right, and then I'm going to, I guess I never drew the end behavior. If I've got an odd degree polynomial with a positive leading coefficient, I'm just really struggling there. I should just give myself a little more room to work, and then it would go better. All right, so if it's an odd degree polynomial with a positive leading coefficient, it's going to look like the graph of y equals x cubed, at least on the outsides, is going to have that end behavior. So I'm going to go and I'm going to plot my zeros. Okay, and then, all right, so it's going to look like this, and then it's going to bounce at x equals 0. It's got to bounce back that way, and then it's going to pass through confidently at x equals 1 because x equals 1 is a single root. And all right, yeah, we've got ourselves x equals 0, a relative maximum. Number 7 is the graph of this polynomial increasing or decreasing at x equals 0, and show your analysis. Okay. Well, this is going to be a 4th degree, because I've got 1, 2, 3, 4 powers of x. It's going to have a positive leading coefficient. Okay, so that means that its end behavior will look like the graph of y equals x to the 2 or y equals x to the 4. The same as any other even degree polynomial with a positive leading coefficient. I'm going to list out my zeros. X equals 0 is a single root. I don't see any exponent. X equals +1 is going to be a double root because of that exponent of 2. And x equals -3 is going to be a single root also. So I go and I plot this, okay, -3, 0, and 1. So I'm going to be respecting the end behavior. Okay, so I'm going to pass through with confidence at -3 and 0 because those are both single roots. So, right, passing through confidently there, bouncing at x equals 1. So if they're asking if we're increasing or decreasing at x equals 0, we're going to look right there at x equals 0, and I'm going to notice that as I move left to right, the graph is going up. So I'm going to say that's increasing. And I think that's going to be all for this quiz. Thanks for watching. Hope this helped.